So how's everybody doing out there? Well, welcome to day 12 of Corona Online School. So hopefully everybody had a good chance to work on their presentation. I can't wait to see what you guys have to do with the presentations today. So today we're finishing up chapter 3, and I really like this section. So this is working in base 5. So this gives you a good opportunity to kind of feel like an elementary school student, when they're first learning about base 10 number system and they really don't have any background or anything to go on. So that's kind of a cool thing about this section, because for the most part you probably never thought about base 5 or maybe even worked much in base 5, if at all. So if you struggle a little bit, that's totally expected. I mean, I kind of get that. I mean, that's kind of what we're practicing it for. And again, it's to kind of give you the feeling of what it's like learning a new number system when you haven't ever worked with one before. All right, so if you remember example 1 from the base 10, I had you kind of write down a bunch of numbers in base 10 in our normal number system. So we want to do kind of the same thing here. So I just want to jot down a few of them to get started. I won't write them all down, but so if we start counting in base 5, we'd have a 0, we'd have a 1, we'd have a 2, we'd have a 3, we'd have a 4. And then kind of just like when we did base 10, once we got up to 9, we had to start over. So we put a 0 in the ones position, and then we moved a 1 over in the next column. So that's what base 5 is going to do for us now. So we can't have the number 5 in there. So once we get to 4, we're going to put a 0 there and then add a 1 in the next position. And then do the same thing. So 1, 1, 1, 2, 1, 3, 1, 4. And then when I get to where there should be a 5, I'm going to get a 0. And now I want to add another one to the next position to get 2, 0. And then we can kind of keep going this way. 2, 1, 2, 2, 2, 3, 2, 4. And again, once I get to here, I can't have 2, 5, so I get a 0. Bump this up to a 3. And then keep going. 3, 1, 3, 2, 3, 3, 3, 4. And again, we have to bump up. So 4, 0, 4, 1, 4, 2, 4, 3, 4, 4. But now once I get here, I'm going to turn this guy into a 0. That's going to put one more in the second column, but that's going to make that a 0 also. And then that means we need to add a 1 to the third column in this case. So that's the first, bunch of numbers in base 5. Also, not to be picky, but if you notice the way I labeled these numbers, like once I got to here, I didn't call that 10. So, because keep in mind, that's a base 10 thing. So when we're actually talking about base 5 numbers, we really just kind of name them by their position. So that's why I was doing 1, 0, 1, 1, 1, 2, 1, 3. So, because the notion of 10 is a base 10 thing, like 20, 100, these are all base 10 things. So you wouldn't want to call this number 100 because it doesn't mean that. It doesn't mean anything in base 5. So we would just call it like 100. And typically we'll see later on, like we're actually going to subscript all these numbers so that we know that they're base 5 to distinguish them from a base 10, since we use the same symbol to represent these two number systems. So, all right. So again, how many digits or symbols does the base 5 number system have? So it has 5, and the digits themselves are 0, 1, 2, 3, and 4. Does the number 5 have a unique digit? So in this case, if there was a number 5, it would be that 1, 0. So it's definitely is unique. It's totally different. There's no 5 even in the number system. And so what happens after the 4 appears in the ones column? So we make a 0 and then add a 1 to the next column. So it's really just like we did for base 10. Once we got to a 9, we made it a 0 and added 1. So not super different. The main thing to keep in mind is we just have a limited number of digits that we can work with. All right. So, and again, just like in section 1, we had a nice place value chart. But in this case, notice instead of having tens, 100s, 1000s, 10,000s. Everything in this case is in terms of fives because we're in a base 5 number system. So the ones is still the same. That position is never going to change regardless of what base you're in. But in this case, our second column is how many fives you have, as opposed to like before, how many tens we had. And then the third column is how many 25s, how many 125s, and then how many 625s in this case. So if I were to write these like in powers of 5, for example, then I would get these as like 5 to the 0, 5 to the 1, 5 to the 2, 5 to the 3, and 5 to the 4 for each of these guys. So each position is going to be an actual 5th power as opposed to a 10th power like we had before. So same thing above, so like the decimal form would just be like 1, 5, 25, 125, and 625. All right, so let's look at some examples here now that we've got that down, hopefully. So in this case, and again, I'd be yelling out, I'd let people yell out answers for this, but I'll have to answer them myself. But if you feel like at home, yell out the answer, that would be totally good. So in this case, write the base 5 number that comes after the following number. So in this case, I've got 22 base 5. So the next number on my list would be 23 base 5. So I would just increase my ones position by 1, or 2 3 base 5. Sorry, you'll catch me making the same mistake, but 2 3 base 5. So what number comes after 3 4 base 5? So in this case, if I added 1 to this, that's going to change that 4 into a 0, and then I need to increase the 3 by 1. So this is going to become 4 0 base 5. And same thing with 1 4 base 5. If I increase it by 1, that's going to make that a 0. Increase the 1 by 1, so that's going to give me a 2 0. So in this case, 2 0 base 5. All right, so what if I was trying to go backwards? What if I was trying to figure out the number that came before? So if I was at 2 0, then in this case, I'm kind of taking 1 away. So in this case, that would put me at 1 4 base 5. And if I was at 4 3 0, then again, if I take 1 away, that's going to put me at 4 2 4. And then finally, 10 base 5. And this one we wrote down above, so you could reference this one if you needed to. This one actually drops back to 4 base 5 in this case. So again, it's good to get comfortable being able to move back and forth between, a before and an after. So now what we want to do is actually practice changing numbers from base 10 to base 5, and then from base 5 back to base 10. So the main thing to remember is when we're trying to convert numbers from base 10 to base 5 is remember base 5 only has the digits, oops, if I can write it right, can only have the digits 0, 1, 2, 3, and 4. So can anybody think of an operation that can be done that will only allow those possible kind of answers? 0, 1, 2, 3, 4. Oh, I think I heard somebody say it. If I were doing division of 5, then those could all be remainders. Because if I divide something by 5, my only possible remainder choices are 0, 1, 2, 3, and 4. And so that's exactly how we actually convert a number from base 10 into base 5, is divide their given number by 5. So what we want to do is divide 136 by 5. Now we have to be careful. There's a little bit of a trick to this. So I'm going to go ahead and write 5 by 136. And then off to the side, I'm going to put some spaces for my number. I don't know how many I'm going to need, so I'm going to start with 4, and I can always add some more. So this is just regular old division, and what we want to do is just keep track of the remainder as we're going along. So in this case, 5 goes into 13 2 times. 13 minus 10 is 3, 36. 5 goes into 36 7 times. Gives me a 35, so my remainder is 1. So I know at this point I need to stop, and so this remainder 1 is going to be part of my base 5 number that I'm trying to construct here. So now this is where it gets a little strange. So when you're filling out your number, your base 5 number, we actually write it in reverse order. So in this case, that first remainder goes in the first position. So it doesn't go in the first number on the left, it actually goes on the first number on the right. So just kind of keep that in mind when you're doing this kind of thing. So in this case, let me put my 1 there. And so now the top number becomes my new inside number. So now I put the 27 on the inside, divide by 5 again. So in this case, 5 goes into 27 5 times. 27 minus 5 gives me a remainder of 2. So at this point, I'm done. I've got a nice remainder that's smaller than 5. So my 2 is going to go in the next position over. So let me write a 2 here. And so now my top number again goes on the inside. And so 5 goes into 5 one time with a 0 remainder. And so be careful here, because you might be tempted to think you're done, but we're not. So the 0 just tells us that that's going to be another one of my digits that I need to fill out. So I'm going to get a 0 in that position. So at this point, since I still have a number on top, I can still divide one more time. So when you stop dividing is when you get a 0 on top. So when you finally get to a position where the 0 is on the top, not the 0 is on the bottom, that's when you know you're done and you're finished with your number. So in this case, I still have one more division I can do. I can divide 5 into 1, but I know I can't, 5 doesn't go into 1 ever, so that gives me a 0 on the top. 0 times 5 is 0, so 1 minus 0 gives me a 1 remainder. And so now that I've got this 0 here, this tells me I'm done in this case. And so this number, whatever it is going to be the very first number of my digits. So that's going to go there. So let me go ahead and fill this guy out. So what it looks like is 136 base 10 is the same thing as 1021 base 5. So again, just divide, and then just make sure when you write your answers in, you just write them in backwards is the idea. So start with the 1's position, then the 5's position, then the 25's position, and then the 125's position when you're writing these guys down. All right, so I've got practice 1, so that's for you guys to do. So if you want to pause the video at this point and try practice 1, A and B, just to give yourself a chance to try converting stuff from base 10 to base 5. And when you do, unpause the video, come back, and then we'll go the other way. We'll go from base 5 to base 10. All right. Everybody okay in this case? Everybody was able to successfully get those 2 done? All right, perfect. So converting from base 5 to base 10 is actually much, much easier, because in this case, all we want to do is kind of rewrite our number in expanded form. But in this case, our expanded form is going to be using a base 5 system. So in this case, what I'm going to do is take 134, and just like we would have wrote this in expanded form for base 10, I'm going to write this as, so the very first one would be 4 times 5 to the 0, plus 3 times 5 to the first, and then 1 times 5 to the second, and then add all those guys together in this case. And whatever your answer is, that is the base 10 number that we actually get. So as long as you can convert, a base 5 number into its expanded form, then you can actually convert anything into base 10. It's not too bad. So in this case, let me kind of simplify this. So 1 times 5 squared is 1 times 25, plus 3 times 5 is 15, plus 4 times 5 to the 0 is just 4 times 1, so just 4. 1 times 25 is 25. So 25 plus 15 is 40, plus 4 looks like we're looking at 44 base 10. So 134 base 5 would be the same thing as 44 base 10 in this case. All right. Or 134. I don't know what I just said, but ignore me. Like, even though I made that big spiel at the beginning, I'm going to mess this up all the time. So if you mess it up, I'm not going to hold it against you. But all right, so take a look at practice 2. So this will have you doing the exact same thing. So you're going to convert something from base 5 into base 10. So again, at this point, pause the video, come back and practice those guys. And so there's actually a bunch of them. So practice 2, practice 3, practice 4 is going back into base 10 to base 5. And then when you're done, unpause and let's talk about some arithmetic. So who knew you could do arithmetic in base 5? But yes, you can. So go do those other practice problems, and when you're done, come on back and we'll look at arithmetic in base 5. All right. So hopefully everybody did a good job of practicing going from base 10 to base 5 and base 5 to base 10. So now, actually using the same things that we learned for base 10 addition, we can actually use that same model to actually do base 5 addition. So now in this case, the only difference, at least for like the mats and the strips and all that kind of stuff, is like our old strip would have consisted of a big long, straight line with 10 blocks in it. And our mat would have been a 10 by 10 block, and like our cube would have been a 10 by 10 by 10 cube. So in this case, everything's going to be base 5. So our strip would be 5 blocks put together. Our mat would be a 5 by 5 mat, and if we had a cube, it would be a 5 by 5 by 5 cube in this case. So what we want to do is first let's rewrite 132 and 243 from base 5 into mats and strips. So in this case, I've got 1 in the 25s position, so that's going to be a mat. I've got 3 in the 5s position, so that's going to be 3 strips. And then I've got 2 in the 1s position, so that's going to be 2 dots. So again, even though the number positions have changed from 10s to 5s and 100s to 25s, like we still treat them the same way. We just need to remember to cash them in earlier. Like we can't wait until we get 10 of something to cash in. We want to get to 5 of something and cash it in. All right, so let's do the same thing for 2, 4, 3. So 2 in the 25s position, 4 in the 5s position, and 3 in the 1s position. And unfortunately, I didn't give myself enough room here, so I'm going to kind of do all the additions over here on the side. So now, again, we just kind of don't worry about grouping or anything like that. Just bring everything down and we'll group last. So in this case, I had 2 dots to begin with, and I've added 3 dots to it. So I've got 5 dots in the first position. So I started off with 3 strips, and to that I'm going to add 4 more. So there's 1, 2, 3, 4, 5, 6, 7 strips, it looks like. And whoops, let me erase this line since it's right in my way. And then I had 1 mat, and then I'm bringing 2 more mats down. And so now is when we do our conversion. So what we want to look and see, is there any of these columns where we have more than 5 things? So for example, right off the bat, I can see I've got 5 dots here. So I can cash those 5 dots in to 1 strip in the 5s position, or the 5s column. And so similarly, I've got 5 strips, so I can take these 5 strips and turn them into a single mat in the 25s position. And so now if I look, it looks like there's nothing else I can combine. So now I can go ahead and bring it down and write it in terms of its base 5 number. So I've got no numbers in the 1s position, so I'm going to bring down a 0. I've got 1, 2, 3 numbers in the 25s position, or the 5s position, so I'll bring down a 3. And then I've got 1, 2, 3, 4 mats, so that means I'm going to get a 4 in the 25s position. So it looks like 132 base 5 plus 243 base 5 is the same thing as 430 base 5. All right. Is that okay with everybody? All right. So these other ones are exactly the same. So I don't know if you want me to go through them, if you guys want to try some of these on your own. So, like, actually, I'll leave place value cards and place value diagrams for you guys to do, just to see how you do. So, remember, place value cards is the one where we're using the dots. Place value diagrams is the one where we would use the numbers. So, in this case, like 132 base 5 would just look like 1, 3 dots in the 5, 2 dots in the 1s, and then 2, 4, 3, we get 2 dots in the 25s, 4 dots in the 5s, and then 3 dots in the 1s. And then again, just do kind of like we did above, just bring all the dots down and then regroup at the end, where if we were doing place value diagrams, we would actually just write the numbers in there. And so again, just like we did before, we don't do any kind of regrouping until after you add. So remember, like 3 plus 2, we would just leave as 5 at the moment. 4 and 3, we would leave as 7. 2 and 1, we would leave as 3. But then, anytime we saw a 5, we would regroup this guy and kind of move 1 over to the next position. So in this case, I'm going to take this 5. Whoops, wrong thing. And I'm going to make it into a 1 in this position down here. And so the 7, so this is where you have to be a little careful, because when we did this in base 10, like we would have had a number like, say, 13, for example. And all we had to do was to take that 1 and just slide it over here and put a 1 here. But since we're in base 10 instead of base 7, or base 5 instead of base 10, we can't just grab that 1 off the front and keep the part in the middle. So what we have to do is kind of think of this in terms of numbers of 5, or if you want to convert 7 into what it looked like base 5, like, and then that would actually work, then you could do it. Otherwise, what you want to do is think of this 7 as like 5 plus 2, and then that would allow you to grab that 5 and then make a 1 in the next position over. And so when I do this, I still have this 2 left over, so let me bring the 2 down, and let me bring that 3 down. So again, there's nothing here, so I can just write a 0. And so I've got a 2 and a 1, so I need to add those guys together to give me a 3. A 3 and a 1, I'll add those guys together to give me a 4. And so in this case, I get 430 base 5. So luckily, same answer as I had above. So I'll let you do the place value cards. So I guess I will show you instructional algorithm just because it's a little weird. So let me write down instructional algorithm. Maybe I'll just do the whole problem. Who knows? So you talked me into it. So 132 base 5, 243 base 5. So this is one where, again, like, it probably helps. So this one, it would help to like probably write down a few of the first numbers, just because, like, to be able to carry, and I'll show you why. So what I'm going to do is I'm going to kind of jot down the first few numbers here, basically up to 9. So this is my base 5 column, and then beside it I'm going to do my base 10. And so what I need to do, and you'll see why in a second, is I want to represent the first 9, oops, I guess you should do them in order, numbers in base 10, and what the equivalent base 5 version of that number would be. So if we remember, 5 base 10 was the same thing as 1, 0, 6 base 10 was 1, 1, 7 was 1, 2, 8 was 1, 3, and 9 was 1, 4. And so for what we need, we won't need to go up, for addition at least, we won't need to go anywhere past that. So you might always want to keep that handy if you're doing addition base 5. And so what we want to do In the instructional algorithm, remember this is the one where we didn't do any kind of carrying. We just actually wrote what the number was equal to. And so in this case, I don't want to do 3 plus 2 is 5 like I did over here because there is no 5 in the chart. So that's why I want to go over here and be like, so the addition we're doing is kind of a base 5 or a base 10 addition, but the answer we want is we want our answer in base 5. So since I added 3 plus 2 and got 5 base 10, then my answer would actually be 10, 0. So in this case, I would add right the 10, 0. So again, I'm starting to line up the things in the 5s columns and the 25 columns, just like we did with the instructional algorithm. So now, same thing, when I add 4 plus 3, so in base 10, that's 7, but I want my answers to be in base 5, so that's going to give me a 12. So in this case, I'm going to get a 1, 2, and a 0 in this case, because again, I'm adding something that's in the 5s column. And so now, finally, I want to add up the 25s column. And so in this case, 2 plus 1 is 3, which is the exact same thing, base 10 or base 5. So that just gives me 300. And so now I can add all these guys up. So 0, 2 plus 1 is 3, 3 plus 1 is 4. And so again, luckily we got the exact same answer, 430, base 5. And so final algorithm, as you can imagine, is going to be just like we did here. I guess I should put additions down here. Except instead of writing the 1, 0, we're going to carry the 1 just like we would in base 10. So 3 plus 2 is 5, but base 10 is, or base 5 is 10, so that would give me a 0. Carry the 1. 4 plus 3 is 7, plus 1 is 8. So now I'll go down to the 8 position. So 8 base 10 is the same as 13 base 5, so that means I'd carry put a 3 here, carry a 1, and then 2 plus 1 plus 1 would give me 430 in this case, base 5. So again, luckily, I did pretty much the whole problem for you, so I still will leave place value cards just for practice, but I did want to show you that there's some subtle things that you need to do to add these using like the instructional and the final. And again, having this little chart handy will make it a little bit easier. So kind of keep that in mind. You may need to write that down somewhere. All right. So if everybody's good with addition, or if I went too fast, feel free to slow the video down, go back and check it out again. I'm going to have some practice problems for you guys to work on also for addition, subtraction, and multiplication, because we will have some of those like on the test. So let's move on to subtraction here. So again, subtraction is going to be exactly like we did subtraction for base 10, except, like when we regroup, we're going to, add 5 dots or add 5 strips or add 5 mats. And again, just like with subtraction base 10, we kind of do all of our regrouping in the beginning and then actually figure out like what our answer is. And then there shouldn't be anything left to regroup. Where addition, we add, then we regroup. So in this case, let's do the 231 or 231 base 5 minus 143 base 5. So again, let's write this out as 2 mats, 3 strips, 1 dot, and then 1 mat, 4 strips, 3 dots. And so maybe I left enough room this time. We'll see. So again, I run into a problem right off the bat because I'm trying to take 3 dots away from 1 dot, but unfortunately I can't do that. I have to have more dots on the top than I do on the bottom. So this is where we want to do our regrouping and cashing in. So I want to take one of these strips and move it over to, so I want to take one of these 5s and break it apart into a bunch of 1s. So again, remember in this case, all of our strips represent 5. So when I bring these over, I'm going to add 5 dots to the mix. So 1, 2, 3, 4, 5. So there's my 5 dots. And now this one is gone. So just a reminder, there's where we cash that in. And so now that I've got more dots on the top than the bottom, now I can do kind of like the takeaway method and subtract these guys. So I can take these 3 from the top with the 3 from the bottom, and that'll go away. So that leaves me still 3 on the bottom. So let me just bring those down. And so now if I look, I've got 2 strips on the top, but I want to take away 4 strips. So again, I'm kind of in the same problem I was last time. I don't have enough strips on top. So let me take one of these mats and turn it into 5 strips. So we want to break this mat apart and turn it into 5 strips. So let me put them over here, and I'm going to have to probably do it tight. So 1, 2, 3, 4, 5. And so now I've got 5, 6, 7 strips on top. So that allows me again to do kind of the takeaway method and just circle, let me circle these 4 here. And again, these 4 are going to go away. So that leaves me still 1, 2, 3. So I've got 3 strips left over in the 5s position. And then remember, this block is gone, or mat is gone. And so finally, I've got 1 block on top, or 1 mat on top, 1 mat on the bottom. So again, using the takeaway method, these guys are just going to cancel out. So all that we're going to be left with is 3 in the 5s position, 3 in the 1s position. So we end up with 3, 3, base 5 in this case. All right. So again, is that okay with everybody? All right. So now that I've done the introduce place value card and place value diagrams to you guys, I'm going to let you do those on your own for extra practice. Hopefully you get 3, 3, base 5. If you don't, check with me to make sure we didn't do something wrong or make sure I didn't mess up or something. But I will show you the instructional algorithm again, because this one again is tricky, but just because of the way you're regrouping and things like that. So again, just for reference, I'm going to do my little chart again just in case I need it. So I got my base 5 and my base 10. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And so again, what was our number? 231 minus 143. So 231 minus 143. So in this case, what I'm going to do is, again, same idea. I need to regroup this guy, but how am I going to regroup it? So I can't do the same trick like we did. Well, you can, I guess, in a way. You just have to be careful and remember kind of what you're subtracting from each other. That's where it gets a little tricky with this guy, because I can't just take this 2 and put a 1 there, because that took a 1 and turned it into like this 6 or something. So we have to be, so we kind of have to be careful a little bit how we group these guys. So what we want to do, well, I guess that's actually okay. Would that work? 11 minus 3. Would it work? I guess it could work. I'm trying to think. Well, because then you'd be subtracting base 5. And I guess the question is, do you want to subtract base 5 or do you want to subtract base 10? I'm assuming you want to subtract base 10, because that would be easier in this case. Yeah, so we want to subtract base 10. So what we're going to do, whoops, I keep hitting the wrong thing. Is when we borrow, we're almost going to kind of rewrite this top number each time. So in this case, again, I'm trying to take 3 from 1, but I know I can't do that. So what I'm going to do is I'm going to take one of these 3's and turn it into a 2, and then I'm basically going to add 5 to this guy over here. So what I'm going to do is rewrite this top number instead of 231 as 226. So that way I've reduced the 5's position by 1, and then now I've actually made it so it's not a base. This isn't a base 10, base 5 number anymore because it's got a 6 in it, but it's going to allow us to subtract in a base 10 way. So kind of keep that in mind. So now I can bring my 143 down. So again, in this case, we're subtracting that first row or first column as a base 10 number. So 6 minus 3 is 3. But in this case, we're kind of stuck again because we can't subtract 2 from 4. So that means we need to rewrite this guy also. So again, I want to take one of these things from the 25's position and then add a 5 to the 5's position. So in this case, instead of bringing the 2 down, I'm going to bring 5 plus 2, which is 7. And then in this case, 1 minus 1, well, that's just going to be 1 in this case. And so now let me bring down just the 1 and the 4 in this case, because I've already dealt with this 3, it's gone. So now in this case, 7 and 4 is going to give me a 3, bring down my other 3, and then the 1 and the 1 is just going to be 0. So that gives me my 33 base 5 in this case. So it's kind of tricky. Addition's a little bit cleaner, I think, than subtraction. So like subtraction's a little uglier in this case, just for that reason. And so final algorithm would try to do this all in a single step. So in this case, I had 2, 3, 1 minus 1, 4, 3. And so again, I'm trying to think like whether this would be, I guess we could write it in base 5, but to subtract in base 3, maybe that would be the cleanest. So in this case, that would allow us to write this as a 2 and then carry this as a 1, but I don't want to subtract this as 11 minus 3 gives me 8, because that wouldn't be, or 11 minus, right, that wouldn't be what I'm looking for, because this is 11 base 5. So if I look, 11 base 5 is the same thing as 6, 3 is the same thing as 3, so what I'm really doing is subtracting 6 minus 3 to get 3 in this case. But I'm writing it so it looks like it's base 5, so it allows me to just carry that 1 over. So I'm kind of like going back and forth between base 5. So I want to write it as base 5, but I want to subtract in base 10, same way we did before. So same thing here. I'm trying to take 4 from 2, but I can't do that. So if I just borrow 1 from the 25's position, break it up into a bunch of 5's, then that's going to give me a 1, 2 in the 5's position, or 12, or 1, 2 dots in the 5's position. So again, 1, 2 is going to be my 7. So I'm subtracting 7 from 4, base 10, which would give me 3, base 5 in this case. And so again, I get the same answer each and every time. So I must be doing it right, which is good. All right. So those are tricky. I don't know if I'll put any instructional or final, like on a test or anything, just because they're a little bit confusing. But maths, place value cards, place value diagrams are all fair game for certain. So, all right. So finally, let's look at a quick multiplication, and then I'll have some for you guys to practice. And so again, notice I didn't even try to do instructional or anything like that on that one, at least. I did do expanded notation for the next one, but so in this case, we're just multiplying a single digit by a single digit. So in this case, if we were writing this with mats and strips, we're still going to use that whole repeated addition idea to do multiplication. So in this case, I'm doing 3 base 5 times 4 base 5. So depending on how I want to write it, let's say I want to do 4 dots, and then the goal is I'm doing that 3 times, so I would just write 4 more dots, and then 4 more dots in this case. And so now, again, what we want to do is once we get 5 of something, that means we can group those together and move a 1 into the 5's position. So in this case, I take this one and that one. That gives me a 5. So that means I can move a strip over in the 1's position. And then it turns out I've got another 5, because I can take this 4 and this 1, and that's going to give me another strip. And so now finally, what's left over, I still have 2 in the 1's position, so I can bring my 2 down. And now I've got 2 strips in the 5 position, so that's going to give me a 2 in the 2nd position. So it looks like 3 base 5 times 4 base 5 is the same thing as 2 base 5. All right, so in this case, we want to do the same thing, except hopefully you notice right away I've got a major mistake on my diagram here, which I'll hopefully fix before I upload it. So this should be the 5's position, This should be the 25's position, and so ones would stay one. So that was a major mistake on my part. Sorry about that. And so again, we would do the exact same thing. So we would again just, since we're doing place value cards, this is all about dots. So again, just like before, I'd have 4 dots, 4 dots, 4 dots. And then again, same idea. I want to group these guys up. So if I grab pink, say, so I can grab 4 of those dots, and that's going to give me a 1 in the 5's position. And then let me use, say, green, and again, grab 5 more. And again, that's going to give me another, oh, I guess I shouldn't use strips. Sorry, these are all dots. Whoops. So let me do this again with dots. So I'll get a dot here, and a dot here. So I'll put my dots there. And so again, these ones that are over here are all just going to cancel out, same way they did over here. So all I'm left with is 2 dots in the 1's position, 2 dots in the 5's position. So again, my final answer would be 2, 2, base 5. All right. So finally, sorry, I know this video is probably getting a little long. So, if at some point in time you've paused it or you've tuned me out and you know how to do this stuff, that's totally good with me. So, all right. So in this case, we're going to multiply a slightly bigger number. So we're going to multiply 2, 1 by 3. And so again, using the place value cards, I'm going to write down 2, 1 and then repeat it 3 times using my repeated addition algorithm. And so again, notice I made a mistake here again. So sorry. Hopefully somebody would have noticed that. And so again, I'm going to get 2 and then another 2 and another 2 because I need to repeat 2, 1 3 times. And so I'm going to get a 1 and a 1 and a 1. And so in this case, when I start to see if I can regroup anything, I've got 3 1s in the first column, so that's totally fine. So I'm just going to bring those down. There's nothing to regroup. But in the second column, in the 5's position, I've got 1, 2, 3, 4, 5. So I've actually got 5 things in the 5's position, which is going to allow me to move 1 over into the 25's position. So I'm going to cash in these ones in blue and turn that into 125. So that leaves me still 1 in the 5's position. So let's bring that down. And I just made a 1 for the 25's position. So in this case, rewriting it, looks like I'm going to get 113 base 5 as my answer in this case. All right. So expanded notation is, again, just like we had for base 10, except in this case, everything's going to be base 5. So the first thing I'd want to do is I'd want to write, 21 as expanded notation. So I'm going to get 2 times 5 to the first plus 1 times 5 to the 0. And then what I'm doing is I'm multiplying that by 3 times 5 to the 0. And so again, just like we did before, I just want to distribute these guys in. And so in this case, 3 times 2 is technically the same thing as 6. But again, we don't have a 6. So again, if you needed to write down the chart, but in this case, 6 base 10 is the same thing as 1, 1 base 5. So in this case, I'd get 1, 1 times 5 to the 1 plus 3 times 1 is 3 times 5 to the 0. And then finally, so the way I wrote it, or again, if you wanted to write it this way, that would be totally fine. So if I wrote it this way, then what that means is I'd have to, again, cash in 5 of those, things I've got there and move them over. Now, if I write it this way, that's telling me that I've got a 1 in the next position over anyway. So I can just kind of carry this over that to the next spot in this case. So in this case, this 1 would actually go over here and be a 1 in the 5 to the second spot. Plus that would keep this 1 in the 5 to the 1 spot. And then finally plus 3 times 5 to the 0 spot. And then collapsing it back down, I'd just get 113 base 5. Or again, if you were using the 6, you could again just turn this into, and notice that this is the same as 5 plus 1. And again, that would allow me to take that 5 and turn it into a 1 times 5 squared. And then I would still keep a 1 times 5 to the 1, plus 3 times 5 to the 0. So however you like to do it, again, expanded notation can be a little tricky, and the final is probably going to be a little tricky too, just for the same reason. So if I were going to do a multiplication, it's probably going to be the place value cards, because it's probably the easier thing to work with. But finally, let's try to do the final and see how bad I mess this up. And so again, this would come in handy for you to keep this chart available, because I'm going to do the multiplications in base 10, but I want to write my answers in base 5. So again, 3 times 1 is 3, base 10, and base 5. So I'm just going to bring the 3 down. And then 3 times 2 is 6, base 10. But since I want my final answer to be in base 5, then it would actually be 11, or 1, 1, sorry, in that case. So I get 113 base 5. So luckily, again, got the same answer each and every time. So again, if this is a little tough for you and a little bit of a struggle, keep that in mind. That's kind of the goal of this section. I don't expect you to be perfect on this section. Again, the main reason we're doing this is to kind of put you in the mindset of what it feels like for a student who's adding in a base system or subtracting or multiplying, having basically just looked at it for the first time and they really don't know that much about it. So it kind of gives you an idea of what elementary school kids feel like when, like they get thrown something new at them, especially when we look at it and are like, how do you not know this? Because they've never seen it, never experienced it. So if you nail all these problems, good for you. Maybe you just have a good base whatever mind, but if you struggle, that's kind of what I expect. So feel free, ask me questions if you have any. Again, I can't wait to see your presentations and stuff like that, and I'll see you guys tomorrow.